Today we're going to be talking about simplifying radicals. And if you look, I have an example of a radical here. Um, this little n here, which is in this little crook here, is called the index of the radical. The number under the radical symbol is the radicand. And for instance, if we have this expression a equals, and we have that same symbol from up above, it's read a is the nth root of b. So in other words, you're looking for what number would you have to raise to the nth power to get b. Now we've got several properties we're going to be talking about here. First of all, the multiplication property of square roots. If you have the square root of ab, that's equal to the square root of a times the square root of b. If a and b are both greater than or equal to 0. You can't take the square root of a negative number, in other words. Next is the division property of square roots, which says for all numbers a and b where a is greater than or equal to 0 and b is greater than 0. The reason b has to be greater than 0 is, notice in the example, b is in the denominator and you can't have a 0 in the denominator. If you have the square root of a over b, that's equal to the square root of a divided by the square root of b. Moving on to the next page, some examples of square roots. Square root of 9. So in this case, you'd want to ask yourself, what number can I square to get 9? That would be 3. Square root of 6x. Is there a number that you could square to get 6? And no, there isn't. There's no number you could square to get x either, so that's simplified. 10 square roots of 5. That means 10 times the square root of 5. Some examples of cube roots. The cube root of 27. So in other words, you're asking yourself, what number do I need to cube to get 27? And that answer would be 3, because 3 to the third power is 27. Next problem, the cube root of 8x cubed y to the 6th. And believe it or not, you can simplify this a bit, because what number can you raise to the third power to get 8? That would be 2. What could you raise to the third power to get x to the third? That would be x. What number can you raise to the third power to get y to the 6th? That would be y squared. Essentially, what you're doing is you're taking each of these exponents and dividing it by the index, this 3 on the outside. So really, you're getting 3 divided by 3 gives you 1. This is like 2x to the first. 6 divided by 3 is 2. So that gives you your y to the second. Next one, 5 times the cube root of 9, and there really is nothing more we can do to simplify that. Some examples of fourth roots. This is the fourth root of 64. So we're looking to simplify this. Now, let me show you, while 64, since there is no number that you can raise to the fourth power to get 64, you can break this down into numbers that would have a fourth root. For instance, 64 you could break down into 16 times 4. And then you ask yourself, could I take the fourth root of either of those? Well, is there a number I could raise to the fourth power and get 16? And yes, that would be 2. So I'm going to move 2 to the outside. I've taken the fourth root of 16, so I don't have to worry about that anymore. And I still have my 4 underneath the radical. Now this next one, let's say we have the fourth root of 9x to the fourth, y to the second, z. Is there a number I could raise to the fourth power to get 9, or could I break that down? No. Can I do anything with this x to the fourth? Yes. What could I raise to the fourth power to get x to the fourth? Well, that would just be x. So I can bring the x out in front of the radical. So that is gone now. Basically, I took that 4 divided by 4. That means I have an x to the first there. Y to the second, I can't divide by 4 and get a whole number, so that's going to stay right where it is. This is like a z to the first. I can't divide the 1 by the 4 and get a whole number, so that's going to stay there. So basically, I've got to leave everything else under the radical sign. So I have 9 y squared z, or z to the first. So I've got x times the fourth root of 9y squared z. And then this last one, negative 6 times the fourth root of 56. And there really is nothing that I can do to simplify this anymore. There's no number I can raise to the fourth power to get 56. There is really no way I can break that down into anything that would have a fourth, um, that would have that would have a fourth root. So I'm just going to have to leave that as it is. Prime factorization. We want to write the prime factorization of these numbers. Uh, Prime factorization means you're going to break everything down into prime numbers. Prime numbers are numbers that can be divided only by 1 and itself. So basically we're going to make a factor tree here. So you want to break 24 down into two numbers that multiply to give you 24. Pick any two. I'm going to choose 6 and 4. Are either of those numbers prime numbers? No. I can divide them by other things besides 1 and itself. So I'm going to break them down again. 6 I can write as 2 times 3. And 4 I can write as 2 times 2. These numbers, 2, 3, and these 2's, are all prime. They can only be divided by 1 in itself. So the way I write the prime factorization is I've got 3 2's here, so I'm going to write that as 2 to the third times this 3. And if I were to actually do this out, 2 to the third times 3, I would find that gave me 24 back. That's a way to check your answer. Let's do the next one. Write the prime factorization of 18. So let's break 18 down into two numbers. How about 9 times 2? 2 is prime, so I'm going to circle that. 9 is not, so I'm going to break that down. 9 is 3 times 3. 3 is prime, so I will circle both 3's. And I'm going to write my answer as 2 times, there are 2 3's, so I'm going to say 3 to the second. 2 times 3 to the second. And that indeed gives you 18 back. Let's go to the next page. Simplifying square roots. If you weren't quite sure what I did right in the beginning when I was simplifying those radicals, now's the time to really catch on. We want to start with the square root of 200. Okay, so let's think about that. There is no number I can raise to the second power and get 200, but maybe I can break that down. What about if I broke it down into 2 times 100? Well, I can take the square root of 100. Square root of 100 is 10, so I'll move that to the front of the radical, and then I'll keep my 2 underneath. And I can't simplify that any further, so it's going to be 10 times the square root of 2. This next one, square root of 45x to the 6th. I can't take the square root of 45 and get a whole number, but I can break that down into, how about 9 times 5, and then I've still got x to the 6th. Well, I can take the square root of 9. Square root of 9 is 3, so that's gone now. I can't take the square root of 5, so that will have to stay there. And x to the 6th. Since we're taking a square root, basically you're going to be dividing exponents by 2. So if I take x to the 6th, I divide 6 by 2, I get x to the third. So since I could do something with that, that's no longer under the radical either. And all I'm left with is that 5 underneath the square root symbol. Next one. Let's say we have the square root of 525. The square root of 525 is equal to, well, we can't take the square root of 525 and get a whole number. So let's see if we can break it down. we could break that into 25 times 21. Now we can take the square root of 25, which is 5, and we're left with the 21 under the radical. And you ask yourself, well, can I break 21 down into anything that has square roots? I could do 7 times 3, and that would be about it. And 1 times 21 isn't going to get us anywhere, so we can't take the square root of either 7 or 3, so we're stuck with 5 square roots of 21. Let's do this next one. We have the square root of 128x to the 4th. We can't take the square root of 128 and get a whole number, but we could break that down into 2 times 64. So we've got 2 times 64x to the 4th. We can take the square root of 64, which is 8, pull that out front. We can't take the square root of 2 and get a whole number, so we'll leave it alone. So 64 is gone. X to the 4th, you take the exponent and divide it by 2 again. So 4 divided by 2 is 2, so we have an x to the 2nd we bring to the outside, and we keep that 2 under the radical. So we have 8x squared square roots of 2. Square root of 99. We can't take the square root of 99 and get a whole number, but we can break it down into 9 times 11. We can take the square root of 9, which is 3, and we have our 11 left under the radical because we can't simplify that one anymore. Let's do the next one. Square root of 32x to the 6th y to the 7th. We'll break that down into 16 times 2 because we can't take the square root of 32 and get a whole number. So the square root of 16 gives us 4. X to the 6th. So divide that by 2. So we get x to the 3rd. Divide the exponent by 2, I mean. Now this next one, this is going to be something a little bit different. So the 16's gone, x to the 6 is gone. Y to the 7th. Divide 7 by 2. Think of it. 2 goes into 7 3 times. 3 times 2 is 6. But we have a remainder of 1, don't we? The remainder stays under the radical. So, because 2 goes into 7 3 times, we're going to put y to the 3rd outside. We have a remainder of 1, so it's like y to the 1st stays underneath it. There's your remainder right there. And we still have the 2 underneath as well. So we end up with an answer of 4x to the 3rd, y to the 3rd, times the square root of 2y. Let's move on. Let's say we want to multiply each radical expression. We have the square root of 3 times the square root of 7. So we just multiply and we get the square root of 21. We can't simplify that any further. Square root of 6 times the square root of 3 gives us the square root of 18. We can simplify that because we can break 18 down into 9 times 2, and we can take the square root of 9, which gives us 3. So we have 3 square roots of 2. Now this next one, 5 square roots of 6 times 3 square roots of 2. You take these are basically like coefficients, the numbers outside of the radicals, and multiply those together. So 5 times 3 gives you 15, and then take the radicals and multiply them together. So square root of 6 times square root of 2 gives you square root of 12. Now, we can simplify the square root of 12 because that breaks down into 4 times 3. We still have our 15 in front. We can take the square root of 4, which gives us 2, put that out front with the 15, and we still have the 3 under the radical. Now, basically, you're multiplying these numbers together that are out front, so we're saying 15 times 2 gives us 30 square roots of 3. So next, we're going to move to some division. Square root of 25 over the square root of 36. Well, square root of 25 is 5. Square root of 36 is 6, and we get 5 6. So next we have the square root of 42 over the square root of 64. Well, the square root of 64, we can take that is 8. Square root of 42, we really can't break that down into anything where we can take a square root. 42 is 6 times 7. It's also 21 times 2. And we really can't take the square root of anything there, so it's going to have to end up staying the square root of 42 over 8. Next, square root of 44 over the square root of y to the 6. Well, we can take the square root of y to the 6. Remember, just divide the exponent by 2, so we get y to the 3rd with no remainder. Square root of 44, we can break that down. 44 breaks down into 4 times 11. And we can take the square root of 4, which is just 2, and we leave the 11 under the radical sign. So we have 2 square roots of 11 over y to the 3rd. Let's move to the last page. Rationalizing the denominator. Now this is something very useful. You never should leave a square root or in the denominator or any kind of radical in the denominator. We're going to deal with just square roots today. And the way you rationalize it is take whatever that square root is, in this case it's the square root of 7, and multiply both the numerator and the denominator by that. So when you do that, square root of 5 times square root of 7 gives you the square root of 35. Square root of 7 times the square root of 7 is just the number back. It's 7. Because if you actually did that out, you have the square root of 49, which just gives you the 7. And we can't simplify the square root of 35 anymore. Let's do the next one. If we want to simplify the square root of 6 over square root of 5, multiply the numerator and the denominator by the square root of 5. So in the numerator we get the square root of 30, and in the denominator square root of 5 times square root of 5 is just 5. And you always ask yourself, can I simplify this? And you think of how you can break down 30. You could do 5 times 6, you could do 2 times 15. There really isn't any way to break that down any further so that you could take the square root of something. So we're stuck with the square root of 30 over 5. And that's all for today. Thank you for joining me.